Okay, so we'll be starting off with question 1, part A firstly. Well, we were asked to calculate the mean of these four variables right here. And we have the 24-hour average mean, the 12-hour average mean, next the last mean, and lastly the volume mean. So in order to calculate these four variables, we had to use this formula called the average first cell of the data in column to the last cell data in column. And for part B, we were told to construct a bar graph that presents our 2015 last average and the 2014 last average. But before we had to construct that, we had to calculate the 2014 last average and the 2015 last average using this formula, the average first cell data in column and to the last cell data in column. And as you can see in the bar graph, the 2014 last average is twice of 2015 last average. And next slide will be part C and D. For part C, we were asked to explain why does the mean of the 12-hour average have such a low value compared to the mean of the 12-hour to the mean of the 24-hour average. Now this is because the extreme values in the 12-hour average data, such as the large number of zeros, brings down the mean of the 12-hour average drastically. And for part D, we were asked why does the 2014 last average and the 2015 last average have such a huge difference between these two, and as 2014 being the bigger one. This is the reasons why. This is because the values of data in 2014 last are exceptionally higher than 2015 last. And as you can see, 2015 last we have 280.23 to 452 to 59. However, on the other hand, the 2014 last we have a whopping 383.2 all the way to 920, which is almost double of 2015. And next, we have part E. Part E, we were asked to calculate the confidence interval, the 95% confidence interval. And firstly, we have to find the sample size, which is 277, which can be calculated using this formula right here. Count first cell data to the last cell data in column. Next, we have to find the 24-hour mean, which was already previously calculated in the previous slide. And next, we have to find the 95% confidence interval, which is just taking norm which is just using this formula right here, norm SINV 1 minus 0.05 over 2. And next, we have to find the sample standard deviation using this formula right here, STDEV dot S, where S stands for sample and first cell data in column to the last cell data in column. Next, we have to use this formula to find the confidence interval. Yes, and in order to find the upper bound, we have to use the plus sign, the positive sign, and in order to find the lower bound, we use the minus sign over here. Yeah. So therefore, it is estimated that we are 95% confident that the population 24-hour average exchange rate lies between 550.925101 and 594.921822. And for part F, we have to construct a hypothesis statement. And firstly, we have to state the null hypothesis, which is 0, which is 560, and the alternative hypothesis, which is the opposite of null hypothesis. So, since the null hypothesis equals to 560, we use the two-tail. And alpha is 0.05 since it is a 5% significance level. So, and in order to find the significance level, there's this formula called norm SINV is bracket 1 minus alpha, which is 0.05 over 2. You get this value right here. After that, you have to find the statistics. But however, since the population standard deviation is unknown and n is more than or equals to 30, we use this formula right here. And after that, we'll find our test statistics, also known as our z. So in conclusion, since our z is more than minus 1.959963985 and less than 1.959963985, z does not lie in the rejection region. Hence, we do not have sufficient evidence to reject the null hypothesis at 5% significance level. And lastly, we have part G. So what I think is the E and F agrees with each other, since when alpha equals to 0.05, population 24-hour average exchange rate lies between 550.9251 and 594.921822, which is the 95% confidence interval. And the test statistics lies between minus 1.959963985 and 1.959963985 at 5% significance level. Thank you.